So we're going to look at K-modes. The resources for K-modes in particular on the internet is quite difficult to understand. It's not something that you could get a lot of responses or results for when you type in Google. So therefore, I'm going to look at giving you an easy way to understand K-modes in an intuitive way, and also a way that you could use to understand the algorithm in a deeper level. So with this, I decided to use a running example, as this will help solidify your understanding much better than if I just if I just mentioned the protocol and nothing else. So I made this analytical record which had 10 individuals. So we have all of these individuals here. So this refers to the instance, or you could use this as an ID measure. So this is person 1, person 2, person 3, all the way up to person 10. And I asked them 5 questions. And in those 5 questions, they could either respond A, B, or C. When we're looking at a response of a categorical variable, because these are not numeric, A, B, and C are not numeric responses. So therefore, we cannot use k-means, as k-means relies on using a mean as an average, and you cannot do averages of categorical variables. It doesn't work as well. So the alternative is to use this new algorithm called K-modes. Not new. It's quite, it was first mentioned in the paper about 20 years ago. So it's quite recent in the scale of things, but not relatively new. So when we look at this analytical records, we're going to look at these steps that I've mentioned. So the first step is to pick an observation at random or instance, whatever you call it, and use that as a cluster. So for cluster 1, I picked to do 3 clusters. I picked 3 arbitrarily. You could decide whatever you want to make it, as long as it's quite reasonable. So for the first cluster, I put, this is cluster number 1. I put the person that I used to initiate the cluster in the brackets. So brackets 1 is in regards to the first individual. Brackets 5 is in regards to the 5th individual, and 10 to the 10th individual. So as you can see, it lines up. So cluster 1, individual 1, A, B, B, A, B, B, C, C. And the same with cluster 2 and individual number 5. So that's the first step, is to initialize the clusters at random by choosing some instances from your data record or analytical record, whatever you want to call it, and run with that as your first 3 clusters, or first however many clusters. So now the second step is to compare each data point in the cluster to each observation data points. Any elements that are not equal, we add 1. If they are equal, nothing is added. That might sound a bit complicated now, but when we run through the example, it'll make a lot more sense. So with this, I picked cluster 1 compared to individual number 1. Since we used individual 1 to make cluster 1, there isn't going to be any differences in our data points, as you can see here. So therefore, we cannot add 1. If we go back to our steps, we add 1 if they are not equal, but they are equal. So we don't add 1 here, we can't add 1 here. So altogether, we have 0 as C1. This is 3 rows that are added. That just refers to a distance away from the cluster. So this individual 1, intuitively, is no distance away from cluster number 1. Now, that's not the same with cluster number 2. If we use cluster 2 for individual number 1 and put that here, so this is, I literally just copied this row over here. Sorry. Copied this row over here, and I put it here just so that we could make the comparison quite easily. So we could see for question 1, individual 1 responds A, cluster 2 has C. So therefore, these are not equal. Question 2, the same, B, and cluster 2 gets C instead. A, C, C, A. So therefore, we use our rule and add 1 to each of the things that don't match, each of the features that don't match. So we get 1 here, 2 here, 3 here, 4 here. So 4 of the features don't match, so we put a distance of 4 from cluster 2. So it might seem that was a bit too easy, or it might seem a bit too basic for it to be right, but that's actually the correct protocol. So we just follow those steps. We do the same with cluster number 3, and we line up the things that don't match. So we can see here, question 3 and question 4 don't match between the individual and the cluster centroid. So here we have 1, 2. So we're going to put here the distance away from cluster 3 is equal to 2. So quite easy. So now I'm not going to do the same for each row. I did this in my own time. It took me about 20 minutes. It takes quite a long time if you want to go through it. If you want to, it will help. You don't need to. I've already done it, and this is what I was left with. So once I do the same protocol that we just did for the first row, just going back, we done this to get the first row. I did the same and repeated it for all of the individuals. So now let's go on to the next step that you're going to need for this algorithm. The next step is to assign each individual to the closest centroid. So I already highlighted the minimum distances from each of these clusters. So for individual 1, that individual is actually closest to cluster 1. This is because they have the minimum distance from the clusters. Intuitively, that makes sense. If not, pause it, think about it for a bit. So I've highlighted all of the minimum values for each row. So you can see here, 2 is the smallest value of these other 2 clusters. So this person will be assigned to cluster 1. Individual number 3, the minimum value is at number 2, is at cluster number 2. So therefore, they're going to be assigned to cluster 2, and so on and so on. Now, the next step is, so this is just to illustrate, I've assigned, for cluster 1, I've assigned individual 1, 2, 6, 7, and 8. So that's 1, 2, 6, 7, and 8, and the rest as you'd expect as well. Now, the step after that is to use each feature should have the modes for each centroid. Okay, so let's try and make sense of this. So this is where the K modes comes in, the name modes comes in. So for this, let's look at the first cluster. So all the people that are assigned to cluster 1, I've highlighted in an orangey color. So this is to just make it easier for you to see. So for cluster 1, these are the values that I came up with, and I'll show you how I did that. So for question 1, cluster 1, the modes for these 5 individuals, the most common response is A. You can see there's 4 A's and 1 C. So therefore, the mode for question 1 will be A, and therefore cluster 1, question 1 would be response A. And you do the same for this one. So there's 3 A's, 1 B, and 1 C. So A is the mode. Here again, the mode is chosen. So it's going to be A because there's 4 A's and 1 B. And repeat the process. You get 3 B's and 1 A and 1 C, etc., etc. If there's a point where you have equal number of responses, just choose any arbitrarily. It's up to you. And then the algorithm will help you resolve that issue later on. That being said, it's not a perfect algorithm. If you start at different places, you're going to end up with different results. That's the flaw of K modes, and even with K means as well. But I'm not going to go too deep into that. Just try and understand this and make sense of this. So I've got the result for A for cluster 1. I repeat this for cluster 2 and cluster 3. And this is how it looks. You could go ahead, pause the video, go back, check if I got it right, just for your own understanding, and maybe if I didn't make a mistake, I'm not too sure, but it would be great for you to check anyway for your understanding. The step after that is quite intuitive. You repeat what you've just done from steps 2 to steps 4. So that's compare each data point in the cluster. So like this, we compare each data point. So this one, they're the same, so you don't have, this is going to be 0. They're different, so this is going to be 1. And then we're going to put a 1 over there and repeat that for all of the clusters. So what we've done before, we're just repeating this process again and again and again. So each one is called one iteration. And then you'd only stop once you reach the point where no changes in assignment is made. So if I'd done this and I've done this process again, and I ended up with the clusters being assigned to individuals 1, 2, 6, 7, and 8 for cluster 1, and 3 and 5 for cluster 2, basically the same over here, and I made no changes, then I'd stop the algorithm. I think in this case, you would have some changes put in place for the next iteration that I haven't yet gone into. I'd like you to do that. But the key point is, once you're no longer making any changes in assignments for the individuals, that's when you should stop the algorithm, and that's when you have your clusters organized. So I hope that makes more sense. Try and finish off the result that I've done, this example that I've done. This is a check for the next step and all of the distances for the clusters. Give it a go, check yourself, make sure it makes sense to you. And yeah, if there's any problems, leave a comment down below and I'll check them out.